Hey guys, so we had a little bit of the snafu in the recording. So this is becoming part 2 of the video. I think I started the 8x plus 1 problem and then I had an issue. So this is somewhere around where we left off. I don't actually, looking at the timer, I don't think we're going to do as many problems as I wanted to do. But let's knock out at least a couple of more and try to squeeze the total under 30 minutes. Hey, we got A and A prime here. I think in the last video I did this a little bit differently at the end, if you caught the end. But looking at this problem, okay, if you take the derivative of 8x plus 1, you get 8. 360 is not 8, but 360 is a multiple of 8. 360 is 8 times 45. And so that's close enough. These two terms, let me underline both terms in red actually. These two terms do not need to be perfect A prime. They need to be A and then just a multiple of A prime. Obviously, if we made 360 the A, the derivative is 0. 8x plus 1 is nothing like 0. So looking at these, we got an original and derivative relationship. And whatever that original is, whatever that A is, that kind of becomes U. That's U, so that's one box that we need. We take our derivative du over dx, and we just get 8. Cross multiply and solve, and we get dx equals du over 8. Now, I only know that because I've already worked this one out. Please actually take this time to write it over 1, cross multiply it. Really be confident. Don't just get lazy and say du over whatever. It's not always true. So we got our boxes, so we're ready to pack up our problem. 360 will stay for the moment. U will be substituted for 8x plus 1. And then du over 8 will be substituted for dx. And look, this is all just kind of chained together by multiplication. So we can really simplify kind of across the expression. So 360 divided by 8 is 45. See here. U to the 44th du. And then look, we can take out coefficients. So the 45 can just kind of hang out. And we just need to think, what is the antiderivative of u to the 44th? That's it. We have taken something that had a lot going on and just really packed it up into a smaller box. So the derivative of u to the 44th is u to the 45th over 5. Right? In terms of the antiderivative step, we've really made life easier. Now our coefficient, right, needs to chill, which is good. It's going to end up actually undoing divide by 45. Don't forget plus c. And then the last thing we want to do is we want to rewrite our answer in terms of x, right? We want to unpack after we move. Not before we move, but after we move, we want to unpack. And if we look 8x plus 1 to the 45th was the chain rule problem you were assigned. Now look, the derivative steps look nothing like the antiderivative steps. That's why mastering chain rule is not necessary to follow this process. Remember, in the future, I'm not going to let you take the answer and do the derivative. You're just going to start with this, not knowing what the answer will be and work towards it. Okay, let's knock out a couple more. Another one from the assignment where we have an A prime relationship. If we look at these, okay, we have cubed and squared. We have to the second, and we have a linear term. So if we look at A is going to be x cubed plus 3x squared plus 1. The derivative for that is 3x squared plus 6x, which isn't exactly like this expression. But if you divide by 3, you wind up with x squared plus 2x. So this is close enough to the A prime for this to be a good, juicy U substitution problem. So let's pick our U. Our U is that original, right? And the reason it's just got to be close is the derivative has to be close enough to help simplify this part of the expression. All right, so that's our U. Let's find our du dx. And then let's solve for dx. And look, I know for a fact that after I cross multiply and divide and move everything around, it comes out like this. You, when you do your own, on your own, you need to be careful and correctly work out dx, and don't just guess. All right, time to rewrite our integral. So this becomes the integral of x squared plus 2x times u. And I feel like I'm missing an exponent here. Yeah, this should be to the fourth. I apologize if for the moment it didn't really show up in any of our work, but there should have been a to the fourth here. And now we got du over 3x squared plus 6x. Now if we look at these expressions, like I said earlier, 3x squared plus 6x is a multiple of this, right? This little term down here is really just 3x squared plus 2x. So there's our common factor. And this 3, remember, this is in the denominator. So we're going to take that all the way out to the front of our integral, right? It's got enough it's got the mathematical ability to get all the way out there. And I'm going to have 1/3. And then this is all that remains from our u substitution. We have rewritten the problem using u's. If you look at the original and I say, think about the antiderivative, your brain would explode. But if we look at this version and I say, what's the antiderivative of u to the fourth? That should be easy. Oh, it's just u to the fifth over 5 plus c. Obviously, 1/3 divided by 5, we can make that 1/15. And the other thing we want to make sure we do is take out the u and replace it in terms of x. So we're going to unpack after we move to the fifth plus c, right? If it was u to the fifth, it's got to be all this to the fifth. And if we look, this was one of the problems we did the chain rule. We did the chain rule for derivatives, and we got that. So we're now doing antiderivatives to reverse that process. I only have time for one more, and I know I said I was going to do that quiz question for free. That will happen, just not in this video, but it will happen. I don't want to break a promise. I think it's better to do the other question that was actually on the half sheet. So this was the answer to the last chain rule problem. The reason I like this one is, what's the a? If we look at kind of these two pieces, obviously the derivative of sine is cosine, but the derivative of cosine is negative sine. So there's like flexibility in the a and the a prime here. We got to pick which one's the a. The choice is whoever is more trapped. Whatever term is more trapped, you need to make that the a. If we make cosine the a, we're going to get stuck. Or if we make cosine the u, we're going to get stuck. So 1/5 sine x, the derivative of that would be 1/5 cosine x, which is a multiple of cosine x. So like we said, we had choices. The better choice for u is the sine because it's trapped. It's buried inside the expression. Whatever's more free-floating, you do not make like the kind of free term the u. So let's go 1/5 sine of x. The derivative is 1/5 cosine x. And then the du dx for this one, like I said, I only know this because I've worked this problem already and I'm trying to save time. By the time you rearrange all of this, you wind up with 5 du over cosine x. All right. So that's one of our boxes. Help our friend move. This is another one of our boxes to help our friend move. So let's pack up their messy room. Cosine x for the moment is going to stay. But instead of this exponent, we're going to substitute in u. So we're going to pack that up. And then dx, we're going to pack that up, although the box is messier than the mess itself. But watch this. And look, that first kind of term, just leave it. Because look, leave it there. It's going to get taken care of on its own. This 5 now, right, we can take that all the way out to the front of the integral. 5 e to the u du. If I ask you to think about the antiderivative of the original, oh my gosh. But we have made the problem easier. Antiderivative of e to the u is e to the u. And that's a c, by the way. And what is u is 1/5 sine x. And this was, I think, our last problem on there. This is it. And all you really need to know coming out of this video is the big picture of taking a complicated looking integral problem and trying to turn it into an easier looking integral problem. That's the goal, right? Just the amount of pieces in this expression is greatly reduced. The overall process is starting with a u by looking for an original that has a derivative, starting with a u, working towards a dx, and then going back and starting to simplify that problem. There's a practice problem I want you to try. We'll go over it at the beginning of class. It's on the video. All right, let's just kind of double check that we got everything. Struggling to click. There we go. Yeah, so I do want you to try this practice problem. I go ahead and give you the u. So you know that u is 2 minus x squared. You need to think, what's the du dx so that you can determine the dx. Once you know the dx, go back up here and try to rewrite this problem as something easier. I know you can do it. All right, I'll see you tomorrow.